Hey all, this is Mark with Omni Embedded, and this is Chapter B in the training series for the Vtrek product. Chapter A was about installation, and hopefully everyone's gotten through that and has a K64 Freedom board that they can use. As far as terminology, let's start with what we mean when we say configurable and reusable software components. These are components that can be used in any project without the need for modification, and we do that by making them configurable. So you enter configuration data, and that way there's no need for updates to the actual component itself. And that means that it's going to need to include, this is part of a design pattern in Vtrek, the code set for this particular component or any configurable component will need to have an _def.h file. And it's going to have enumerated constants and structure definitions for the configurable parameters. The actual configuration data is in a monolithic structure that you'll find in the data service config.h and config.cpp files that are at this location. So you can go peruse those and see how configuration data is represented in the code set. If you're developing a new component, you need to thoroughly test it during development, or it should be, and therefore you probably won't be required to continue testing it for future projects because you're only changing configuration data, and so that's a time and cost saver. And if you use good object-oriented programming and design practices, the component should be safe for reuse. That's the goal, at least. Okay, you're going to hear us refer to CPP, which is actually the C++ language in these modules. Project specific, when you hear that term, those are code files that are unique to the product that you're currently developing. They can't be reused anywhere else, so they're completely unique, and they don't need to follow the design patterns for reusable code. When we talk about business logic, these are files that you'll create once you start using Vtrek, and they will coincide with blocks of functionality that you typically are using in your product line. So if your product line is engine controls or hydraulics or whatever, you'll be developing a library of source code that's configurable and reusable that you can use on future projects with just configuration changes, as opposed to having to tweak code every time you get onto a different project. So any functions and features that you use commonly for all of your generations of product, you can build up your own library. If it's hydraulics, as an example, there's a good chance you're using force valves in your designs. And so you could create a closed loop force valve feature or control that's configurable, and then reuse that same control for every force valve that you use in future projects or generations. The Vtrex source library is the library of components that's included in the Vtrek package, and those, as we saw in Chapter A, are located at this path after you've done your installation. If you hear us refer to SRS, we're talking about the software requirement specification, or whatever your company calls it. This is a set of requirements for a particular product's functionality. Okay, if you hear us talk about Eclipse or GNU, Eclipse is the IDE. It's free. It's the one that's typically used for ARM-based microcontroller development and builds. GNU is the free compiler for ARM-based, and our tools are really built to some extent around Eclipse. So if you're using a different product for your IDE, there may be some functionality in the ProDev tool that's not going to support your IDE. Vtrek ProDev is a PC application. It's a tool that comes with the package. It supports creating new projects, selecting components that you want to include in your project's build. It'll create standardized format code files so that you don't have to do a copy and paste and then delete everything in a code file so that you keep the same format. And it also has code snippets that can fill in a form, and it'll insert code snippets that saves a lot of typing. These two areas are extensible. You can, through a fairly simple language, create and add your own code file patterns and code snippets. Ddc stands for Diagnostics and Development Communication, and this is a comm stack that we use to communicate with a product. We can use it to flash code, read fault statistics, clear faults, view and override data items, and you can also use it to perform validation testing. The Ddc Tool is an application that utilizes the functionality that's provided in Ddc and provides you with an interface so that you can use that during development, and you could also use it in the field. You can also write your own interface if you want to narrow the scope of what a particular tool would do. Okay, I want to walk through the various code set blocks, and we're going to look at some slides directly after this that goes through each block and what it's about. But in terms of learning acronyms, DC is a data center, which encapsulates data items and methods, and essentially it creates a data dictionary for the variables in your code set in your particular project. UTL is for a utilities library, which is a code toolbox that comes with Vtrek. Sys is for system-related settings and methods. HWA is a hardware abstraction block. HWI is a hardware interface. SVC is for services. So these are commonly needed services that by a server client model. ADP is for adapters, and adapters are used to bring in third-party products to the framework. So they're basically an interface. They adapt to the framework. Feature is a component that comes from your product design or business logic library that pertains to one of the functions that your SRS has defined. So these would be features for a particular product generation or product model. And controls are similar to features, but they're closed loop control components that implement closed loop functionality. Those are put into separate blocks, even though they all fit under the business logic heading. And the only reason we do that is that closed loop versus non-closed loop control is usually a different talent or skill within your team. And so this gives your team a way to keep the closed loop versus non-closed loop functions and components separated. Okay, before we get into the block diagrams, I want to talk about the agent channel design pattern. You're going to see this in many areas in the Vtrek library, in the code set. So the pattern fits a circumstance where you have two or more instances of an object that's required. So for an example, if you've got a SPI port and you've got multiple devices on the SPI port, so the agent would be the SPI port and the channels would be the multiple devices that are on that port. And if you want to go up one more step, you could have multiple SPI ports with multiple devices. So there's a hierarchy here of agent and channel. A to D channels are a really good example as well. So you have maybe a couple of ports of A to D inputs. Every A to D pin you could consider a channel. And so the agent channel pattern applies to that. The agent's purpose in this case is to instantiate channels and then provide any kind of global support to those channels that would reduce code overhead. Digital I/O is another example. If you have motor control and there's multiple motors, you may have an agent channel class where each channel is a motor. The agent is a singleton, and its primary purpose is to instantiate the channels and feed the channels with configuration data that it obtains from the configuration library. The channel class implements all functionality required for each channel. So the presumption here is that every channel is going to do the same thing, which would be true on an A to D channel. If you've got enough functionality in your design and configurability, you can get one channel design to fit all requirements. and then configure it as needed. It's always configurable. We say nearly always configurable, but reality is it's unusual for it not to be a configurable component. And so that means it's going to have the _def.h file as part of the design. And if you go look at analog inputs at this location, that's really a good example of an agent channel application. Typically, if you're into non-reusable designs, like software components that really only apply to one product variant, this isn't a required design pattern or a good design pattern to use, but in many other places it is. So this block diagram is the one that we use throughout the training series, and we keep it pretty much in this shape so that it becomes recognizable. And I want to go through each of the blocks in here so that we've got some definition on what they all mean. And starting at the bottom three blocks are really working together to provide a interface to the rest of the Vtrek framework. The HWI, which is a hardware interface, the HWA, hardware abstraction, and then PSP, which is the processor support package that a lot of the microcontroller vendors supply one for you now. That's fairly recent. That's the last, 6, 8, 10 years. And it really saves a lot of work. It's generous of the suppliers to supply that, because now you're calling upon tested code as opposed to having to create your own hardware abstraction layer and write values to registers and have to debug and learn how to do that. We're hopefully using some tested code now with the PSP. Some suppliers call it a BSP, which I think is a little bit of a misnomer, because a board support package presumes that we know the board's design, and in the case of embedded, every board design is different. So unlike PC, where you've got a pretty much predefined set of I/O. And so in order to abstract that from our Vtrek library, we throw a thin abstraction layer, the HWA. Omni Embedded creates ports for various microcontroller families that we're supporting. And you can also create your own. The design pattern is there, and so if you want to jump onto a microcontroller that we're not supporting yet, it really doesn't take that much effort to create the HWA for that particular micro. And then the hardware interface becomes, compared to a BIOS in the PC world, it standardizes all of the hardware I/O into a set of interfaces that the rest of the Vtrek framework can call upon. And so the HWI is where hardware related variability ends, and everything that you do above that, including the HWI, everything that you do is going to be calling standardized interfaces. So that's the end of Part A. Let's move on to Part B.